Yes, greetings to you, our viewers. This is Tumuharire Kirabo Timothy, welding instructor at Kazo Technical School. I once again welcome you to Kazo Technical School. In our today's education video, we are going to discuss mostly about MIG welding. Please move the camera this side so that we look at this machine. Yes, hope you can see there is on this machine they put their Pro MIG 250/1, and here they are having MIG/MMA. This is IGBT, that's the technology inside. But we can't just rush to talk about MIG welding without first understanding what is MIG welding, and is it the only welding process we have. So with that, we are going to also talk about the most common welding process we mostly see on the roadside, which is shielded metal arc welding. But this machine, if you look closely here, they put on it MMA/TIG welding on top there, meaning TIG is also another welding process. And this is in our introduction. I'm briefly going to talk about all of them, then we concentrate on our topic, which is MIG welding. What is MIG welding? MIG welding is basically a short form metal inert gas, but the technical name is gas metal arc welding, which you can also have the short form of GMAW. G, that's gas, M is metal, A is arc, then W is welding. All these processes are arc welding processes. So TIG is also short form for gas tungsten arc welding. We're not going to go so much in details, but TIG is tungsten arc welding, which is also gas tungsten arc welding. Then this MMA we looked at here. This MMA is manual metal arc welding, which technically we call shielded metal arc welding, which can also have a short form of SMAW. Then basically those are the most common arc welding processes. What do you call them arc welding processes? For you to weld using all these processes, you need to first establish an electrical arc, as you are going to see. So as I was telling you about the differences between all these three arc welding processes, we talked about MIG welding process, which is here. Here we have shielded metal arc welding, or what we call MMA. Then the other side, on this side, we have a machine here. We have our student is practicing here. He's practicing how to weld aluminium. Welding aluminium using TIG welding. The most observable difference between all these welding processes is I have to get my helmet, but please I'll not look this side. The most observable, when it stops, we shall is the torch. When it's done, I'll show you the torch. The most observable about these welding processes is the torch, but the machine is there. We shall also look at it. That's basically for TIG welding, welding aluminium. Excuse me. Let's look at this. So when you look at the TIG welding torch, you can see how it looks like. This is first time whether you understand the technical terminology is known. When you look at the torches, you see the difference. This kind of torch is for TIG welding. Then when you come this side, this torch, actually here we call it an electrode holder. You can see also the difference. This one is for manual metal arc welding. Technically what we call shielded metal arc welding. This is the most common one you see, where we get our electrodes, and if you are going to weld, you have to put them here. That's why we call it electrode holder. We rarely call it welding torch. Then I'll show you the connection, and for it its setup is, I would say, the basic one. It's more simpler. When you come to our MIG welding, well, our torch is also different from the other two. Our torch, how would I describe this? It's more of like, I don't want to call it a gun, but you can see, yeah. The other observable thing about this on this torch, there is this wire which is coming out here. This wire acts as our electrode. We shall see when we go into details of MIG welding, because that's our topic for today. Basically, that's how you can tell the difference between all these processes. But technically, we are going to dive into how do they work, what's inside this box. Let's start with, let's concentrate on our MIG welding, then later we shall going to also look at briefly the other processes, and we shall also weld with them, and we see how they differ. And theoretically, we shall have to know which one should you choose if you are to buy, which one is best, which has advantages and disadvantages. MIG, as you can see, the most obvious setback for it is portability. You can see you have a cut here. To move it, you can see it's not that easy, and it has a cylinder behind here. But this, should metal welding, we have just only this machine. You can easily move it around, meaning you have, if you have sights, this will be easily portable to take on different welding sites. So this is all. This is the metal welding. Then the tip should also look at it. Its portability is also not a little bit related to that of MIG, because it also has a cylinder like the one you are seeing here. But for now, please let me have your attention and we look at MIG welding in details. So inside our box here, we are going to disassemble it. We have our wire spool here, and we can't just move it out. I'm going to move it out and you see it very well. Before we move it out, there are some key details you need to do. So here we have our wire spool. Inside here we have our drive. So when you open here, there are some rollers here onto which that wire I showed you, which pulls it towards the torch. I will show you practically, but basically this is the drive which pulls the wire spool, as we shall see. Then behind here we have our carbon dioxide cylinder. Yeah, you can have either carbon dioxide cylinder. So when you have carbon dioxide cylinder, it becomes metal active gas. So we tend to use them interchangeably. MIG, MAG. MAG is metal active gas. MIG, metal inert gas. The inert gas which we would have here is argon gas and probably some other inert gases. Helium. You can have mixes. You can mix different gases. You can have argon carbon dioxide mixture, which you rarely do. But technically, when you go into studying these processes, you realize that there is a lot also with the gases. But I'm not going to go into those details. But this is a carbon dioxide cylinder. And what does it do? Basically, if you know a little bit about welding, welding is joining two metals together. You have different metals, you melt them at the joint, then they become molten pool. Then that molten pool, as it's cooling, it fuses together. So using the arc is our heat source. It is the one which heats them up to molten point. But in that process of melting those metals to establish the molten pool, you don't want atmospheric gases to go in there. So meaning we need to find a way of chasing away such gases. For example, we need to chase away oxygen. That's the most common one. But the other gas, we need to chase away hydrogen and other atmospheric gases. When they come in, they spoil our bed. Technically, we say they create defects in the weld bead. We shall have a video where we talk about welds in specific, and we talk about weld quality. We have our video when we were doing our testing, and in that video I had to inspect the welds which were done for defects. So those defects are tend to be caused by one of the causes is improper shielding of the weld bead. To understand this, if you are local like us, if you know the process of making charcoal, when they are making charcoal, you cut your wood and you see they cover soil on that wood which they are going to turn into charcoal. Why do they do that? Is they want to prevent oxygen from coming in to burn the wood into turning it into ash. Even us here, when we are welding, as welding, we need to control the heat we put there and the weld itself. It's like you are burning something there, you are burning the metal. But you just want to burn it into molten pool without, let's say, in common language, I would say without turning it into ash. Technically, we would call it, we don't want it, we don't want oxidation take place there. So that's why we need shielding gas. I will show you also for this welding where we use these electrodes. The reason why we also have this flux, the major reason is this flux as we're welding, it also burns, it gives off shielding gas. That shielding gas chases away the contaminant gases, the atmospheric gases, oxygen. So our cylinders there, then here we have the regulator. This regulator is to control the gas which is coming here. We can't use the pressure as it is in the gas here. We need to regulate it. Then we receive it here at the torch here. So here at our torch, of course, here we have the switch. Then here we have our nozzle. So this nozzle can come off. When it comes off, here we have our contact tip. The first one here is the contact tip. Then this is the gas diffuser. The other shielding gas from the cylinder passes here, goes out through the nozzle to protect the weld bead around here. This is our filler wire, which comes from the box inside here. So for disassembling, now the wire is already here. If you look closely here at the wire, you can see once they stopped welding, it made the ball here. So now this ball, if you try to just pull the wire out, this ball will end up increasing the hole inside the contact tip. So meaning you have to first cut off here. Yeah.